Hello and welcome back to another fun lesson in geometry. We are in Chapter 8, Section 3, Proving Triangles Similar by Side, 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 and Side, Angle, Side. All right, the Side, Side, Side Similarity Theorem says if corresponding sides are similar to each other, so for example, AB to RS, or BC to ST, or CA is congruent to TR. If all three of those are true, then those triangles are similar. Corresponding sides are proportional, then the triangles are similar. So using that, I'd want to look at these, and first I'd figure out the short sides, then I could check the longest side, and then the middlest side, or the last one that's not the short or the long side, right? So between the first two, we've got 8 and 6. So I'd set up a proportion 8 to 6, and then we can simplify that down to 4/3. Then we can look at the longest side, that's 16 to 12, and then simplify that down. That's also 4/3. Now we check the third side, that's 12 to 9. Simplify that down. Notice all of these have the same proportion. They simplify down to the same fraction, so that means that these two triangles are similar because all sides are proportional. We could check these last two also. We have the longest side 16 to 16, so that would simplify down to 1. And then the shortest side is 8 and 8. And just by looking at this, I can see here we have 12 and 10. Those are not the same proportion. So these two, ABC and HJG, GHJ, are not proportional, are not similar. So using the similarity theorem, if we have two triangles like this and we have some variables, I can set that up with sides that I do know. In this case, the 4, which corresponds to the 12, I could set up a proportion there, 4 to 12. And then over on the other side, I'd want to pick one of the sides that I don't know. So now I use x minus 1. So for that, I'm going to use the 18. In order to solve this now, remember we can cross multiply or faster than that. Because I want to get the x minus 1 by itself, all I have to do is take the 18, multiply both sides by 18. What happens is the 18 goes up here. And then I get 4 times 18 over 12 is equal to x minus 1. I can simplify this fraction out, or you can type it in your calculator. 18 and 12 can be simplified by 6. I get 3 and 2. And then 4 and 2 can be simplified by 2. Then I get 2 over 1. So x minus 1, 2 times 3 is 6. Plus 1, x is 7. And then I can plug that in here, and they should all be proportional. All right, the side-angle-side similarity theorem. It's very important that the angle is between the sides that you have. Side, angle, side, in that order. So if we have side, then this angle and this side. For this one, we need this side, the angle in between again, and the side. So if that's true, if those are proportional, and the angles are congruent, then the triangles are similar. Okay, using the side-angle-side similarity theorem, if we're building a lean-to shelter starting from a tree branch as shown, can you construct the right end so it's similar to the left end using the angle measure and the lengths shown? So remember side, angle, side. If I have this side and an angle, here I have this side and this angle, so that's 10 to 15. Right? And then I'd want to check to see, are those proportional to these 9 to 6? So simplify these down. Here I get 3 over 2. Simplify this one down. That's also 3 over 2. So yes, these are proportional. I can build it so they're similar. All right, here's a summary. We've got the angle-angle similarity theorem. So where we have two angles. The side-side-side similarity theorem, if the sides are proportional, or side-angle-side, and very important that it's the angle in between the two sides. So those are our triangle similarity theorems. Good times in the matherhood.